So I just wanted to make a little update video. Earlier this week I was streaming my physics debugging and I figured out one of the bugs. I can go over the problem so I can zoom in and you can see that the circle bounces off of the capsule. It doesn't flop over immediately. When we drop it onto the circle, it explodes. That's one of the problems I had. And then the other one was that when the capsule is deeply interpenetrating a line, it doesn't know how to resolve itself. Ideally it should push itself out of that collision, but it doesn't. So lots of stuff that I had wrong. And so what I thought it was initially was how I calculate the relative velocity between the bodies when they collide. I just thought I had a sign error, and I technically did. It's just that my operator overload in the impulse equation itself, I can go to like dpn down here. I take that, like I have an A rigid body and a B rigid body, and I subtract the velocities from each other. And so this little thing right here, the negative B velocity, what that does is it calls a very, very bad operator overload that I had, where I pass in the memory, and then that memory, I negate the x and the y variables of the vector. So I just flip the velocity every time I calculate the relative velocity. So I guess technically it was a sign error, but it was very, very bad. And we can comment that out. And the other problem that I had was, I can show you over here, when the capsule is intersecting that line, it doesn't know how to resolve itself. What happens is that you have these two line segments. A capsule is a line segment expanded with a radius, and there's another line segment down here. And when they intersect, the normal becomes degenerate because the closest point on both lines overlaps, so the engine doesn't know which direction to resolve in. And so you can resolve that by just taking the far point of the capsule surface. I can't remember exactly what it was. I ground out all of yesterday, but I can show you that I'm drawing a little ghost capsule telling us where it should resolve to. And as soon as they start interpenetrating, I just pick, it's in the direction of the line segment within the capsule. I just take the furthest extent on the capsule segment, and that's the surface point, and I subtract it from the intersection point, and that gives me the penetration distance to resolve to. So that's what it looks like, and I can show you the code for it in the engine, if I can go to the right one, and we add this code back in, compile it, and then we'll run it. And you'll see that the circle bounces off the capsule, it falls over immediately. That looks correct. We'll drop the capsule on top of the circle, and hey, look, it's resolving correctly. Wow, look at that. They push each other out. That was another issue where I got confused by what the separation value should be. Now the separation is the distance between the surface points on either shape. So you have like the point on the capsule versus the point on the circle. And when they're negative, that means they're penetrating, so you push them apart. And that's what it looks like when you do the circle versus capsule. And the same thing happens when you're intersecting the line with the capsule. Now it knows how to resolve the collision. So bunch of work, a bunch of desmos stuff that I've been doing. What I'm working on now is now that I have capsules working, capsules are resolving against circles and lines, now I want to add in oriented bounding boxes, squares, so that's like the only other shape I would want to add aside from triangles. Maybe I'll add triangles at some point. And so I'm just trying to validate my mental model by using desmos. First I was going with the separating axis theorem, where I thought, I could use the separating axis theorem between this oriented bounding box and this line. But the problem with that is that the separating axis theorem assumes that you have some kind of positive penetration when the objects overlap. Like you see these little blue dotted lines, they're overlapping the line, but down here the maximum penetration is basically 0. And you can't get any larger than that because the line has no thickness. So the next idea I had is that I read an article that shows you the slab test, and I think this is the better one. This is the slab test where you have a line intersecting an axis-aligned bounding box, and you get the entry and exit values. You see these little points, the min x phase, the min the max X face, the min X face, like depending on whatever orientation the line is in, you can see the penetration points, but that doesn't exactly tell you the contact points that like when the axis aligned bounding box is penetrating the line, it doesn't tell you the corners of that box that you want to resolve from. And so then I had a better idea where you project every single corner against the line and check if it's within the bounds, and then I also highlight it so you can see this little penetrating thing as soon as there is a penetration. And I even account for, oh, what if one of the endpoints of the line is penetrating the box but nothing else is. So the next feature that I'm going to add is I have the regular physics engine update. I have a snapshot system where I can roll back stuff. So this is the regular physics engine. I have the snapshot system, so I can I reset it, please. Man, yeah. So this is the snapshot system. The next idea that I have is I think I made videos about this earlier, but I had like just a static system where I could move objects around and penetrate them with each other. I'm going to add that next just to start. So I don't need to go through Desmos. I can just verify everything directly in my engine, like turn my engine into its own little Desmos thing. That's the next step. Aside from that, I spent today, aside from working on the axis aligned bounding box versus line collisions all day in Desmos, I also ported all that Perlin noise code over to my engine just for the 2D stuff. So I have all these particles, like it's Christmas, so it's snowing in the engine. And so I have a bunch of different rendering features. So here's the little snow particles, and I'm passing them through this little Perlin flow field where I have all these little arrows showing the direction that the particle should move once it's near it. So here's all those snow particles passing through those arrows. Here's what the Perlin noise field looks like, where every single value is just a floating value ranging from 0 to 1, and you can apply a sine and a cosine to that to get a direction to figure out which direction it's pointing, and that's what the arrow field is. It gets super slow right here because I'm alpha blending every single pixel, and this is a HD resolution monitor, so you can see the performance here is chugging, and we're going really slow. So we're getting to a point where I might want to start thinking about optimizing like SIMD or just putting it into the graphics card, but this is just a little, I'm drawing 1,000 particles right here and they're all alpha blended circles, so I don't need to do this. It's just a nice little snowing effect. But maybe in the future. Eventually I want to start thinking about optimizing, but right now I'm still focused on physics. This is just a little holiday thing, so Merry Christmas. Thanks for watching. I'll catch you later. Bye-bye.